For those of you that don't know me, I'm Michael Taranto, and tonight I'm going to be talking about teaching CSS to talk more like a designer and why this should be the focus of our development teams. Developers and designers often speak very different languages, and for how closely they work together, that can be problematic. CSS gives us the illusion that it understands what designers are talking about, taunting us with these properties like line height and baseline. But more often than not, the output that we receive has diverged from the designer's intent. For example, how would you take a 21 pixel size heading and spread it over a 27 pixel line height? Sounds simple, right? I'm going to define a rule, font size, line height, pump in those values, and we should be right to go. Include my rule on an HTML element and render it to the screen. Magic, or not. So on the left we're seeing what the web's providing us, and on the right is what the designer was intending to see. So the difference between the web and design line heights and baselines, on the left the web centers the specified font size within the line height that has been specified, whereas in a true typographic sense that's measured from the baseline of the text as highlighted in blue on the right. So devs are left to CSS this solution until it works. So we're going to go back and wrestle this rule, maybe add a bit of padding to push the text down, a little bit more padding, maybe another pixel. I think 4 should do it actually. And that's had the fantastic output of now pushing my neighbouring element down, so I'm just going to pull that backwards a little bit more. And finally we're going to maybe land at -3. And I think that should now start to look something like what the designer wanted. But the system left behind is completely fragile and based on pixel values only. And the unfortunate thing is we've taken all those design inputs that we had at the start of the discussion and we've just thrown them away because we've had to now do this bespoke nudging to get the web to understand what the designer really wanted. And the biggest shame here is that good design is not an accident. You don't get this for free. There's a lot of time and research that goes into making a design or a wireframe that by not understanding the intent behind that, we're just wasting a whole lot of time when we're building product. We're all pretty familiar at the start of a project. Both design and developers will look to a grid system of some sort to provide some sane structures to our applications. And we'll often implement a type hierarchy of some sort, defining headings and subheadings, etc. And at the outset, we've got the very best intentions, so we'll take the rows and the columns and the dimensions that we're using in our conversations with the designers, and we'll model them in variables, capture our heading sizes, etc., so that we can use these through our system. So if we return to the example I used previously, I can now bring those values in. Even though they're hard-coded, they're in a variable, right? So that saves me, that makes it okay. But I've still got my offset hacks. What we're not doing is we're not fixing this problem. All we've done is centralize those pixel values, but we haven't solved anything in terms of fixing the need to nudge on the screen. So let's unpack some of the differences between the design world and the web here. If we're to move this text down, we need to understand how far down we need to shift it in order to align with the designer's intent predictably. And it's a factor of 2 parts. So the first of which is the height of the descender. So the descender is basically any portion of the font that kind of dips down below the baseline of the text. So in this case, the G, but your Y's, your F's, anything that goes below that baseline. So I've highlighted that in blue. Unfortunately, this isn't available to us in CSS. So we're going to have to do some manual trickery, so bear with me. So we're going to calculate in pixels the height of our descender. So I've got a little tool here that's going to demonstrate. As I move up, it's telling me that this line is getting closer to the baseline. So I'm 1 pixel closer, 2 pixels, 3 pixels should about do it. So that's So that's telling me the height of that descender, the bottom portion of that G there, is 3 pixels high. So rather than have a magic padding, or sorry, a magic margin bottom that we had previously, this can probably start to use 3 pixels. So I'm going to capture that as the heading descender height and put that with my hacks. The other part that I need to calculate or understand is that the font is centered in the line height, which means that half of the line height is going to get in the way of my text sitting on the baseline as the designer intended. So for me to calculate the bottom blue bar as displayed on the screen there, I need to take half of the difference between the line height and the font size. So stay with me, it's very simple math, but the 27 pixels that we're asked to put on the screen for the line height, we're going to minus the font size, leaving us with 6 pixels. And then we're going to divide by 2 because we only wanted that bottom blue bar as forming part of that translation to move the text down to baseline. And we'll put that in a variable too. So heading line height offset, I'm going to call that. So what we end up with is a whole sea of blue variables and no white values on the screen. So there are fewer accidents in this code now. So I've defined my heading offset as being the descender height plus the line height offset, or half of. And so this is the output. So we can see that it's sitting on the baseline. I can now use those variables to compose the CSS that I need to, and it's going to form a predictable output that the designer's happy with. There'll probably be a couple of headings in what you're building, so we're going to want to do this multiple times, and there's a whole heap of ways we could solve this, be it an atomic CSS approach, or if you're using a preprocessor, we can use things like, in this case, a less mix-in. So I'm going to centralize those rules into a mix-in called heading text in my example here. So that what that really represents is that if any of these properties change, I need to consider changing the other properties. But this is an encapsulated unit that should be considered whole. And then at implementation time, we can simply go down to our card heading and use heading text. So the great thing here is we've stopped talking about pixels with the designers. The language is now, can I have a heading inside my card? And I don't need to care about the values of the heading. I just know I can put a heading using that mix-in or using that rule, and it's going to align with what the designer wants. However, that solution is hard-coded, so we need to iterate on this. So what I've divided up here is the 2 separate sections that we've landed on. We've got our design principles that are the heading side and the line height that were kind of coming out of that discussion with the designers, but then we've kind of tucked our offset hacks away in this little commented section as well. So bear with me, we're going to work through this together. What we considered to be design principles, the designers are still having to translate. So that 21 pixels and 27 pixels for the line height is not how the designers are wanting to work. They're translating that to the medium that we're having to build in. So they're finding the pixel values, going back to their sketch or Photoshop, calculating the pixels, and coming back to us with a final number that we need to build. It's good I haven't coughed yet. So what I want to do is unpack some of those numbers. I want to walk through reverse engineering where that 21 pixels and 27 pixels came from, because if we can understand that, we can build something that scales a little bit more fluidly. In a grid-based system, any vertical spacing is a factor of rows. We define our rows early on and we use them for maybe some margins or some spacing between cards, but we don't often flow it through our type. So this line height of 27 pixels can be expressed as a factor of our grid rows. So here my row height is 9 pixels, so my line height is really just 3 grid rows. And that's probably what you'll find the designer was working with to start with, but they've come to us with the final value that they're after. So if that's the case, where does the font size come from? 21 pixels, it sounds like a magic number to me. This was a bit of a revelation for me. I was talking with the designer on the team, and the way he put it was the values in a typographic hierarchy are all a scale of some kind of base size. He said he tends to work off a base of 10 pixels, so that everything scales cleanly. But the importance is the relationship between the elements in the hierarchy. So he operates on scales rather than the end values. But of course, he's translating to the end values so that he can communicate with the developers. So let's capture that in our rule here. Let's represent the base font size as 10 pixels, but then specify our font size as being a multiplier of that. So I know it's been a lot of variable defining, but what we've distilled down to here is our heading is 2.1 in terms of a scale, and it's running over 3 grid rows. So when we extract these principles, we're no longer looking at pixel values that represent our typography. We've got the lower level primitives of the base font size and the row height that we're all working off, and they're fine to be in pixel values, particularly row height, because that probably is the case for the designer. But the heading, scale, and row span is not in pixel values and forms part of our calculation. Again, we still have the offset hacks, but we're going to work through this. So to recap, that spec that I read out at the book end of the talk was 21 pixel heading running over 27 pixel line height. Our language is now shifted to be a 2.1 scale piece of text running over 3 grid rows. And our CSS now captures exactly those principles as the designer thinks about things. So if we want to change values, we're talking on the same page. Speaking of changing values, what if we want to add another element to this hierarchy? So hopefully to really cement what's just happened, let's go through and add a subheading to our hierarchy. So we can now cleanly add a subheading scale and row span, but now we're going to have to revisit all our trickery to calculate the descender height and the line height and add them together to create another offset that's bespoke to the subheading. If they're using the same font, is that descender on the letter G that we saw not just a scale of the font in its entire height? Why would we have to calculate multiple values that are based on the final pixel when we can calculate it as a scale? So let's now dig into how we could express that offset as a scale of the type based on the font family. And when we express things as scale of type, CSS is perfect for this, providing us M units. So we're going to revisit our demo that we used before, but instead of shifting in pixel values, we're now going to shift in M units. So what we're seeing here is the descender scale is 1% of the height of the text that we're looking at here, the entire heading text. And as I raise this number, that green line, hopefully you can see up there, is moving gradually closer to the true baseline. And so when we land at roughly around 15%, that is now a percentage that represents the descender height for this font family. So regardless of the pixel value or the final output font size, we have a scale that we can express. So I no longer need to define this subheading descender height, and I can go back to my heading descender height and blow that away and represent it simply as Roboto descender scale, because that was the font that you were looking at on the screen. So a descender in the Roboto font family on the web is 15% of its full height. So you can imagine you wouldn't have to calculate that value often, because how often do you add font families to your hierarchy? You might introduce different levels of type, but font families is something that you probably calculate a lot fewer or a lot less often. So again, we're going to push around some math now and refactor what we had, but we've now got what can be defined as a Roboto offset, where we take that descender scale and we multiply it by the base font size. So we now know what our Roboto offset is, and we can then multiply that by the scale of the relevant hierarchy element. So either the subheading scale or the heading scale. But as I mentioned earlier, there's two parts to this transform. The other part is the heading line height offset, and we still haven't calculated this for the subheading. So we've done a whole heap of math, a whole bunch of more variables, but we're still not done. Are we really expected to do this for every level of the hierarchy? and what happens when designers want to introduce a new level. So I've written a little library that I've open source called Basekick that goes through translating what are the design principles that we need to put into the system, and the output from that system being the CSS translation required to meet the designer's intent and correct line heights for the web. So again, my implementation here is less, but there's a couple of different flavors in the library. And we're dealing with all the scales and variables that we just saw earlier. So we're taking the heading scale of 2.1. We're taking the Roboto descender scale, which was that 0.15 value. We want it to run over the 3 grid rows for the headings, and our grid rows are 9 pixels and base font size at 10. So we already have these values. Instead of having to calculate them, we just pass them off to a function to generate the values for us. So the output ends up looking very similar to the start of this slide deck, where we specified the font size and line height. But instead of stipulating the end state, we've provided a calculation to generate that, which leaves us free to refactor those design principles through conversation with the design team and have the output reflect that without having these hard-coded values around the place. And you'll also notice we're now leveraging M units for translating the text back down onto the true baseline. Now the reason for using the transforms means we don't need to worry about that margin bottom shifting. We're not affecting our neighbours, we're just shifting the text itself down onto the baseline. And likewise, it leaves those properties of padding and margin to remain semantic. We can use them for adding a grid row above or below a heading, or laying out anything else around the card, which I think is important that we don't take over those properties and then someone could inadvertently override this offset, which we don't want happening. So if we revisit stage 2 of this talk around implementing a subheading, all I need to do now is talk to the design team about what a subheading looks like. And we define it as 1.8 scale, running over 3 grid rows as well. So let's put it to the test. Again, we're looking at Roboto, and you can see that our heading is running over 3 grid rows. So there's the third line here representing the 3 grid rows, and it's sitting perfectly on the baseline. If I flip to Zapfino, which has a drastically different descender, you can see that profile stretching down over 2 grid rows. The text is still sitting on the baseline, but we only have to calculate the font family offset once. Nothing else changes in this system. Papyrus, doesn't matter. Comic Sans for all I care, doesn't matter. So the difference between the implementation under the cover, you can see the second value there, Roboto descender scale, Zapfino, Papyrus. None of the type hierarchy had to change to support that. We just needed to pass in the right scale that represented the descender, and everything else just makes for the correct values. So you can imagine the quality of the conversations we're now having with the design team is it's no longer sending them back to their machine to translate pixel values and then get back to me, send me an email or Slack me. We just talk about these low-level primitives, define them in the system, and we're finished. So as you can probably gather, this takes some time to accrue some research and an implementation like this. So we've been doing this for some 2.5 years at Seek at the moment, and the language has matured considerably since it started. So the hierarchy's grown, for one. When we first started, we had, I think, 4 or 3 type levels, but we needed something between hero and heading text, so we introduced headline, and it was a 2-line change. As we've pushed into delivering responsive web products, we wanted to have our base copy size change as we responsively change the windows. So we introduced mobile scales. The base copy jumps up to a 1.8 scale when you get below a certain breakpoint. That's the change. And because of the ease of use of this system, we've been able to roll it across at least 10 projects now. And it doesn't matter whether the project is using Angular or React or whatever framework of the month they want to choose. We're fixing CSS at the lowest level that we can find. And that just happens behind the gateway of give me heading text. No one cares. So the proof's in production. Let's flip over and have a look So this is the Seek site. And if I drop a, just have to zoom. Oh, I don't know if we're going to see the grey on this projector, are we? Oh, that's very subtle. That's really unfortunate. It lacks a punch. Can you see? Can you faintly make out the grey stripes? So if you focus on the job search, 150k jobs, that navigation, you can kind of see that there's 5 grid rows there marked out. So that navigation, because it affects vertical height, is only a factor of grid rows. The fields, the text, everything sits exactly on the grid rows. So this might be a little bit, you can faintly see this grey line here. So every heading of every job and every advertiser in these ads is all sitting perfectly on grid. So when a designer is playing around with the structure of these job ads, as they're moving the elements around in their system, we can shuffle them here. We can change the debt negotiators level of text to be a subheading, and it will just bump down to the next grid row and take up however much space it needs. And as mentioned, most developers don't even know the system exists because it's low enough down that they're able to have the conversation in a nice pure language with the design team and not need to know that this never lined up under the covers. So CSS is now speaking the same language as our designers, and our code is better for it. But it's been a really deep, powerful mindset change for both disciplines to put so much work into trying to find this level of alignment, because the easy way, we've trained designers to hand us pixel values. Our specs need to be saturated in all these little low-level output values rather than taking the principles, engineering that to have the desired output. Because of the benefit we've been able to have off this system, we decided to apply some of this thinking to our markup and take things a little bit further. It's not just CSS. What if we could teach HTML to speak the same design language that our developers and designers are starting to use? There's a whole heap of component frameworks and libraries around. Our weapon of choice is React at Seek, but it provides a powerful abstraction where you can basically create your own HTML that follows your team's design language and under the covers implements all the rules as your design team see fit. So what we saw previously, where I still had to specify a heading element, define a class name, go off to my style sheet, create a class, pull in a mix in, I can now just use a text component and I get that all out of the box. And using the prop interface in React, and everyone's got their version of it, I can now request a heading, subheading, whatever I like. That blue, well, it's not really blue on the projector, but that heading before the closing tag there is a modifier of sorts. So rather than discussing code like this and pulling either a product owner or a designer over to talk about what a card looks like in a particular implementation, we're not only declaratively composing our UIs like this, but the conversation is super, super semantic. So we're able to look at this and say, no, you know what? This card should have a subheading, or actually between this level, we could do with like some kind of summary that was a subheading. And the product manager could write that if they wanted to. Like it's really, really easy to work with. So the code's much more approachable. Much more approachable for not only our development teams, but also for new starters. We've got to think any new starters joining the team need to pick up our DSL and run with it. Having a whole component suite that just implements this design theory is really important. So it matches the designer's intent out of the box. So hopefully, I know it got a little bit trying at times with a bit of the math, but I'm hoping that this inspires you to go back and work with your designers and developers to really understand the intent that underpins all these decisions, because without having these conversations, we're just going to end up pushing pixels around a screen for eternity, and every time someone changes something, it's going to be this giant refactor. So I think there's a lot of power in moving down this direction. That's me. as I said, Basekick's up on my GitHub. Happy to chat to people about it more afterwards. The slides will be up on that URL. I'll also tweet it out, but it's not up there just yet. So thank you.